In the last video, we set up our game's window and camera by using the view settings in the Room Inspector. And while that certainly gets the job done, it is far from the perfect solution. In this video, we're going to upgrade that system to move that needle a little closer to perfection. I'll explain the general process GameMaker follows to render your game, and give you some tools to really customize the end result. But first, let's talk about some of the problems with what we had at the end of the first video. Problem number 1. I'm lazy and don't want to have to do this every time I create a room. Game dev is often tedious, so whenever I have a good opportunity to reduce that tedium, I take it. Having to open up those view settings, check the same boxes, and plug in the same numbers every time I add a new room is super annoying. Beyond that, what happens if you decide you want to change your camera size? Now you have to go through each room and update the settings in every single one. An ideal system would set things up so we never have to go into those view settings, ever. Problem number 2. Always locked on following. The object following setting is pretty rigid. Assuming you've set the border settings to be locked on the player, they are going to be locked on. And even if you've given a bit of a border, it's still going to follow rigidly when the object moves out of that border. It's very rare these days to have such a stiff camera in a 2D game. Getting away from the object following setting will give us more control over how the camera moves in all situations, and allow for smooth movement and special effects like screen shake. Problem number 3. Locked to the room. This one's pretty straightforward. When using the object following setting, the camera can't go out of the room. It's not possible. If you are making a game that shouldn't be confined to a finite room space, such as an infinite runner or a space sim, then you just can't use object following. The camera will hit the edge of the room eventually, regardless of how big you make it. Problem number 4. Subpixel jittering. This issue is much more complicated than the others I've discussed so far. What we are looking at here is an object that is a single pixel sitting in a room that has a pixel grid as a background. So every square you see here represents a single pixel in our game. The camera width and height is 5 by 5, and the viewport settings are set to 1000 by 1000. That means GameMaker has scaled everything up. Every 1 pixel square you see here is represented by a 200 pixel square in the game window. That means if my object is moving at very, very low speeds, we can actually see the difference between an X position of 128 and 128.1 or 128.2. Now, the other interesting thing about this demonstration is that I have set the camera to follow this pixel object with no border. So as I move, you would expect the camera to follow it and keep the pixel perfectly centered, but that is not happening. That's because the camera position when using object following is automatically locked to a whole number. So until my object has moved a whole number, it won't follow. Watch what happens when I hold down right. The camera appears to jump to catch up. Obviously, I've exaggerated this issue to demonstrate it. This is very likely to happen in your game if your window is larger than your camera, and it will be noticeable to you and the player. The easiest way to fix it is to just not use object following and control your camera through code, where it won't be locked to whole number positions. I labeled this video as intermediate, and to me that means we can get into some of the technical stuff. So let's break down all the elements that come together to render your game on screen and get some terminology solidified so we can have a more coherent discussion moving forward. And just to be really clear about this, everything gets more complicated if you are attempting split screen multiplayer and trying to have multiple active viewports in your room. That would be its very own tutorial video. What I'm covering here is targeted at non-split screen games with a single visible viewport. We start with your room. In your room, there are 8 different viewports listed, but, as I just said, we are only going to be dealing with one. The viewport has a camera assigned to it by default, so you shouldn't need to create or assign cameras in most cases. But the camera itself isn't really important. We aren't going to do anything with it directly. What's important is the view inside the camera. A view controls the area of your room that the player can see. Moving the view changes where the camera is looking and resizing it effectively changes the camera's zoom. Everything the view can see is drawn to the application surface. We'll talk more about this dude in detail later. He is super important. While your game is running, we'll always have a window. Even in full screen, we are still in a window that is just the size of the display. By default, GameMaker draws your application surface scaled proportionally to fit your window. If your application surface and window don't share an aspect ratio, this will result in black bars. Finally, GameMaker draws everything in your GUI event stretched to fit the dimension of the application surface. If your GUI is not sized properly, it will squish and stretch to line up with the application surface. So when we talk about setting all of this up in code, we are really only going to be concerned with 4 primary things: the window, the application surface, the view, and the GUI. We aren't going to use any functions that deal with viewports, so you can probably understand why translating what we did in the room settings to using code is extra confusing. Okay, I think we're ready to actually build this thing. Back in our project, the first step is to add a new room. I always have an initialization room that serves as a place to set up persistent controller objects and get the game ready to play. I'm going to call mine room Init and set it as the starting room. Nothing about this room is that important, but the room size will determine our initial window size, which should be on screen for only a fraction of a second. I usually set this to be pretty small. Let's go with 100 by 100 for now. Next, we need the aforementioned persistent controller object. I'm going to create a new object called Object Camera, set it as persistent, and drop it into my room Init. This object is going to be responsible for doing everything we were doing in the room settings and more, but we are going to do things in a slightly different order than we did in the last video. Let's add a create event. In the previous video, the first thing we did was set a window size and then decide on a view size based on that. But the size of your game's window can change. Even just swapping between full screen and windowed mode changes your window size, and giving your player an option to select a window scale is super common. So basing your game's resolution on something that can change so easily isn't a great idea. Instead, we are going to base our game size on the most common monitor and TV resolution, 1920 by 1080. That's going to be the window size when in full screen the vast majority of the time. To calculate our game's base resolution, we were going to do the same process we learned in the last video. Divide both 1920 and 1080 by a number and use that result as our size. If your game is pixel art, divide it by a whole number, 2, 3, 4, etc. You will design your game based on this result. You'll build rooms, create art, and design enemy behavior with this size in mind. You can change it later, but you'll want to lock this in pretty early on, as changing it late in development can have consequences. So once you finish this video, be sure to come back and experiment with different values. The art I'm using is very small pixel art, so I'm going to divide 1920 and 1080 by 6 and store the result in 2 variables. That will give me a base size of 320 by 180. Exactly what we were using in the last video. Next, we need to set our window size. For now, we're going to assume you are not starting your game in full screen mode. So there are 2 things we need to consider when calculating our window size. 1, we need it to be the same aspect ratio as our view to avoid having black bars. 2, we need it to fit on the current monitor. If the size of the window plus the header bar is too wide or tall for the current monitor's resolution, Windows will squish your window down and make everything look bad. The easiest way to satisfy that first item is to make our window size a scalar that we multiply our base size by. To do that, we are going to divide the display height by the base height, store it in a var, and then we'll do the same thing for our width. Now we need to worry about the second item, making sure the window fits on the current monitor. If the window scale we calculated is a whole number, that means that the base height scales perfectly to the current monitor vertical resolution. And if we set our window to that height, it doesn't account for the header bar, and Windows is gonna get mad. So if we detect that the height scalar is a whole number, we just want to reduce our max height scale by 1. We can use the frac function to do this. If you give the frac function a number, it returns whatever is after the decimal point. And if that's a 0, then the number you passed it was a whole number. We don't really need to worry about this same issue for the width in most cases. The window width can be up to the exact width of your display. From here, we just pick the lowest of our 2 scale values and store that as our window scale. And if our art is pixel art, which mine is, we'll floor that value to make sure it's a whole number. Then, set the window size by multiplying our base width and base height by window scale, and center it. The next line we are going to write twice and comment one out at a time so that you can experiment with it and see what you like better for your game. If you use the top one, you are enforcing a strict pixel grid. Pixels will always line up with one another perfectly, just like an old school video game. However, if you use the bottom one, you'll be enabling what I call subpixels, and everything will scroll, scale, and rotate much more smoothly. Your game will effectively be rendered at a higher resolution. This is purely personal preference for your project, and there are pros and cons to both. So, after we get everything set up, be sure to come back and try changing which one is commented out to see which works best for you. Next, we need to set our GUI size. I'm not going to get too into how the GUI layer works in this video, but we need to at least set our size so that when you start using the GUI, it isn't stretched or distorted. As with most things, this all comes down to giving it a size that shares an aspect ratio with the view and the application surface. For now, we are just going to set it to our base width and height. The last thing the create event is going to do for us is switch to the first real room of our game. So I'll call room goto and give it the actual game room. I'm really only doing this here because I don't have a more senior game manager object to control this sort of thing. This probably shouldn't be the responsibility of your camera object, but it's the best thing we have right now, so that's where I'm putting it. But we aren't quite done with this object yet. In the last video, we checked a few boxes in the viewport settings that we haven't checked in code yet. The first box we checked was the enable view settings. We need to do this one time at the start of each room we enter. So let's add a room start event to our camera object. To check the views enabled checkbox, we use the code viewEnabled equals true. The other option we checked was the visible box inside the viewport 0 group. To do that with code is simple. View visible sub 0 equals true. If the view is enabled and visible, it should probably be sized properly. Let's go ahead and do that here. Camera set view size, view camera sub 0, base width, base height. View camera is a built-in variable that lets us access the cameras assigned to a specific viewport in the room. Since we aren't doing split screen, anytime we need to do anything with a camera, we'll be referencing view camera 0. The last thing we are going to do in the room start event is not technically necessary, but it's just to prevent issues I've seen people run into with my older camera tutorials. If you already have a bunch of rooms set up to use the object following setting, we can reset that setting in code, so you don't have to go back through every room and reset it manually. Camera set view target, view camera sub 0, no one. If you keep the object following target set in the room settings and try to manually position your camera through code like we're going to, you can cause some pretty weird problems. Make sure you don't skip this step. The next thing is we need to reset all of the viewport settings back to default. If you messed with the viewport position or size in the room inspector, especially if you set the viewport size to 0 by 0, things aren't going to work right. So we'll just reset those. And again, outside of setting things up for split screen, this is the only time we'll use these port functions. And that's the room start event done. It's time to get the camera following our character. Let's add an end step event to the object. Why end step? Because we are making the assumption that the object your camera wants to follow is updating its position in the step event. We definitely don't want the camera to position itself to look at an object and then have that object move away from it. We can't have the camera follow the player if the player doesn't exist. So that's the first thing we check. If there's no player, there's nothing to do. Exit. If the player does exist, just set the camera's position to the player. Camera set view position, view camera sub 0, object player.x, object player.y. Let's run that and appreciate a job well done. Oh, right. It's unfortunately a bit more complicated than that. When you use camera set view position, we aren't setting the position of the view based on the center of the view. We are setting it based on the top left corner. So we need to do a little bit of math to find where the top left corner should be when the player is in the center. To do this math, we are going to need the view's current dimensions. Now, we don't want to use our base width and base height here. We always want to use the current view dimensions, though this is more important if you add support for zooming your camera in and out. Still a good practice. var view w equals camera get view width, view camera sub 0. And we'll do the same thing for the height. Then we just take our player's position and subtract half the width and half the height to calculate our target position. We'll use that to set our view position. And we'll run that. And there we go. Now the player is perfectly centered. But wasn't I just complaining about the object following setting being locked on like this? We should probably fix that. But I will say there are situations where leaving it like this makes sense. If your game uses mouse aiming, having a smooth camera means that a player's aim can change even when they don't move the mouse or the character. The camera movement alone alters their aim, which can be sort of annoying. So locking the camera perfectly to the character means the mouse aiming is more consistent. But this project doesn't use mouse aiming, so let's just smooth this camera out. To do this, we are going to use lerp. If you aren't familiar with lerp, it has a lot of amazing uses and is probably one of my favorite built-in functions in GameMaker. We are going to utilize it today to move a value towards a target value by a percentage of the remaining distance every step, which means that we need our camera's current position. var cur view x equals camera get view x view camera sub 0. And then we do the same for the y. We have our current view position and we know where we want the camera to end up. We can use lerp to get a position between those two based on a given percentage. Let's use 20% and see how that feels. tar x equals lerp from our current position to our target position by 0.2 or 20%. To understand what this is doing, you can imagine a line where our current view position is on the left, let's pretend it's 200, and our target position is on the right, let's pretend that is 250. I ask lerp to give me the value that is 20% of the way along this line, 210. So the camera is going to move from 200 to 210 this step, 10 pixels to the right. But as it moves closer to its target, the distance it moves each step gets smaller and smaller, making the camera appear to slow down gradually as it approaches, which is a really nice effect you'll see in many, many games. Let's see what this looks like. Looks pretty good. The last step is to keep the camera locked to the room. Again, there are some situations where you might not want this, but you usually will. Fortunately, it's pretty simple. We'll use clamp to take one number, our target position specifically, and restrict it to a range. And what's the number we want to restrict it to? Well, probably 0 on the lower end. A view position of less than 0 is outside of the room to the left, so that probably means our upper boundary is the width of the room. Before we restrict the y-axis, let's test that real quick. Works great on the left edge. Let's move to the right. Oh, of course. Our tar x is talking about where the top left corner of the view is going to be. So we need to take the width of the view into account to make sure that the right edge of the view can't leave the room. It's a simple change. We'll just subtract the width of the view from the width of the room and use that value as our upper bound. And we'll test one more time. Perfect. So we can do the same thing for the Y target, but using the room and view height. Let's run one last time. And there we go. The camera smoothly follows the player, it's locked to the room, and everything is scaled perfectly and looks crisp. Now's the time to do some experimentation. Try changing that 0.2 value we used in the lerp. What happens if you set it to 0.01 or 0.5 or even 1? Go back to the create event and try dividing 1920 and 1080 by different numbers. If your game art isn't pixel art, try messing with non-whole numbers. And don't forget to mess with those two different surface resize lines to see how that changes things. At this point, it's possible as you've been plugging in your own numbers and experimenting with things, you may have run into some weird rendering issues. Maybe your game isn't scaling correctly, things are distorted, rows of pixels are doubling up or going missing. Something's wrong, and you aren't sure what. If you were to ask in the GM Discord server, I would likely throw this script at you. Display write all specs. There's a link in the description below. I'm going to bring this script in and call it in the draw GUI event of the camera object. Now, when I run the game, there's a bunch of information about how the game is rendering. For each row, you see the element, the aspect ratio, and the amount of scaling relative to its parent element. To demonstrate, I'm going to open my camera object's create event, and instead of calculating the base width and height based on 1920 by 1080, I'm just going to pick some random numbers, 300 by 200. Now let's run again and see what we get. So we can see my monitor is 1920 by 1080 with an aspect ratio of 1.78. Everything else has an aspect ratio of 1.5. Just by looking at those numbers, I know I'm going to have black bars in full screen because the display and the app surface don't share an aspect ratio. But since everything from the window down does share an aspect ratio and I'm not currently in full screen mode, everything is rendered perfectly. If your game uses pixel art, those scale values should really be all whole numbers. But we'll talk about what you can do when they aren't in a future video. I'm going to leave this info up on screen from now on, and I recommend you do the same in your project. If you're having problems and what I cover in this series doesn't help you understand and solve those problems, having that info available when you ask in the GM Discord server is going to really help. I want to take a few minutes to call out two other functions on my Helpful Scripts GitHub that can help issues that pop up when you've enabled subpixels in your game. Sometimes you might see a strange issue where there appear to be like black lines between tiles or on the edge of sprites that aren't supposed to be there. It will often happen while your camera is moving, but if you stop the camera at a precise location, you can make it persist as well. In cases like these, I replace every usage of camera set view position with my camera set view position subpixel script. It's used exactly the same as camera set view position, so if you are seeing that issue, it's super easy to swap out for this function. Can't guarantee it will solve all these issues, but I've seen it help before. There's a link in the description. Another issue you might have is if you're leaving objects at non-whole number positions. In this project, I have these white boxes where a random floating point number has been added to their positions. And while it might be very difficult to see on this video, as I drag the view around, they sort of wiggle and jitter a tiny bit. If you're seeing this, I use a script called draw self-extended subpixel. This is an enhanced version of my draw self-extended script specifically for this issue. All draw self-extended does is call draw sprite extended, but with all of the arguments defaulted to use the appropriate built-in variables, sprite index, image index, xy, etc. The subpixel variant adds some math based on the scale of the view to the application surface and rounds the drawing position. This leaves less up to the floating point math gods and gives you a more coherent image while the camera moves. Again, link in the description. That's all I have for this video. In the next, I'll fix some obvious issues and implement some very common camera features you probably want in your game. I'll reorganize some of this code to be more manageable and reusable, and will also allow the player to swap between full screen and windowed mode, and even cycle through different window sizes. If you have questions, want to get help with GameMaker, or even just hang out with other GameMaker users and talk shop, I recommend joining the GameMaker Discord server. I've put a link in the description. Until then, thanks for watching. Now go make something awesome.